Hi, in this video we will discuss direct form to structure. So we know that in order to analyze the filter we have different form of structures, right? Direct form 1, direct form 2, parallel and cascade. In the previous video I have discussed direct form 1 structure along with one problem. Um, in this video, we will discuss direct form 2 structure with one problem. In the direct form 2 structure, okay, this structure is better than the direct form 1 structure. We will see why this direct form 2 structure is better than the direct form 1. Okay, you know very well the general difference equation of the system, right? So y of n is equal to minus summation k is equal to 1 to n a subscript k y of n minus k plus summation k is equal to 0 to m b subscript k x of n minus k, right? This is the input representation, this is the output representation, right? This is the b subscript k, this is the coefficient of input. A subscript k, this is the coefficient of output. So we will write this equation, difference equation, as a transfer function, right? So here you know very well. So in order to convert time domain signal to frequency domain in the continuous system, we will use Laplace transform, right? But here we are discussing discrete time system. So here in order to convert discrete time system to frequency domain system, we will use Z transform, right? This is the Z transform representation of system. Okay, transfer function h of z is equal to the ratio of output divided by input, right? H of z is equal to y of z divided by x of z. Okay, how we got this equation? So we will see. Just you have to convert this equation, discrete time equation, into z transfer equation. Okay, see here, just I will show you y of z, right? Y of z is equal to minus a subscript k y of z minus k, right? Plus just I have to use this, I have forget summation k is equal to 1 to n plus summation k is equal to 0 to m p subscript k x of, one second, this is y of z, z to the power of minus k. This is the z transform representation, x of z, z to the power of minus k. That's all. Okay. Y of z is equal to summation minus summation k is equal to 1 to n a subscript k y of z, z to the power of, how we will write this one, a subscript k y of z, okay, z to the power of minus k. Okay, similarly here also b subscript k x of z, okay, z to the power of minus k, right? Just you have to take this first half of the equation, okay, you have to take in the um, left hand side, okay, so it becomes plus, it becomes plus. Then you have to take this y of z as a common factor outside, then it becomes 1 plus summation k is equal to 1 to n a subscript k z to the power of minus k. Then this second half of the equation retains in the RHS side. Then you have to do just you have to separate as a y of z divided by x of z. See here, if you are doing cross multiplication, you will get this equation only. Okay, so you have to arrange this equation like this. Okay, so by using this equation, right, this is the one of the general system transfer function. Okay, so for this transfer function we are going to draw the structure, direct form to structure. So we will see how to draw the direct form to structure by using this equation. Okay, see here, so for this system, so the first step is we have to split the system like this. Just I have multiplied and divided by w of z, then it becomes like this. This is one transfer function, this is another transfer function, y of z divided by w of z, and another one is w of z divided by x of z. Here we will assign the w of z value as a 1. Okay, so first I will take this function, right? See here, w of z divided by x of z. I have taken w of z value as 1 divided by the remaining equation. I will retain here, similarly here. Okay, I'm not changing anything, just I have changed the w of z value as a 1 and x of z, this is x of z. I have taken the same equation, 1 plus summation k is equal to 1 to the power of n, 1 to n a subscript k set to the power of minus k. Now we have to do cross multiplication. Okay, we have to do cross multiplication. It becomes w of z, then this equation, right, and is equal to x of z. Thereafter we have to multiply this w of z with this equation, then we will get this equation. Okay, then thereafter we have to take this w of z is a output. Now this is a w of z is a output. The remaining equation we have to take at the, we have to transfer at the RHS side. Okay, it becomes minus x of z minus w of z summation k is equal to 1 to n a subscript k z to the power of minus k. Now we have to describe this equation. That's just we have to substitute the k value 1 to n, right? As it is summation, after the each term, after the each term we have to put plus symbol, because here we are using a summation equation, right? So here the k value is 1, a subscript 1 z to the power of k value is minus 1. This is the first term. Similarly, we have to substitute the k value as 2, a subscript 2 z to the power of minus 2. This is the second term. The third term is, so here we have to substitute k value as a 3, a subscript 3 z to the power of minus 3, and so on. Finally, so minus a, here the final value is n, right? A subscript n z to the power of minus n. Okay, now we have to take another Another function, transfer function, this one, y of z divided by w of z. See, y of z divided by w of z. So as I said before, this w of z value is 1. See here in the above equation, just I will put here, for example, just think here, this is a w of z, means I have to put the value is 1. This is 1, it becomes 1. So I have only y of z summation k is equal to 0 to m b subscript k z to the power of minus k. Okay, see here, that is the second half of the equation, right? Again, you have to describe this equation, right? So just you have to take this w of z here, right? W of z here. See in the second equation, just you have to describe this equation. So it becomes, so just substitute the k value 0 to m. So first the k value is 0, b naught, z to the power of minus 0 means 1, right? You know very well, z to the power of 0 value is 1, right? So b1, next value, the k value is 1. So b1 set to the power of minus 1. Similarly, you have to substitute up the k value up to m, b to the power of b subscript m, z to the power of minus m. So thereafter, you have to multiply this w of z with this equation. So it becomes like this. Okay. Afterwards, you have to convert the z transform equation to discrete time equation. That's all. Okay, this is the second equation. Our first equation is this one. This is our first equation, right? What it becomes, if we are converting time domain to z domain, this is the equation. Now we are converting z domain to again time domain. It becomes w of n is equal to x of n minus a into w of n minus 1, because the delay element is z to the power of minus 1. So it becomes w of n minus 1 plus a subscript to w of n minus 2 plus a3 w of n minus 3 and so on. We will see whether that equation is correct or not. See here, w of n is equal to x of n minus a subscript 1 w of n minus 1, right? So it goes like this, and again we will see here. So we are converting from this frequency domain to time domain. Y of z means y of n. It becomes b naught w of n plus b1 w of n minus 1 plus b2 w of n minus 2, b subscript m w of n minus m. That's all. This is our second equation, right? So by using this equation, so we will draw the direct form to structure. Okay, see here, first I will take this equation as a 1. This is our second equation, right? It's the structure of first equation. This is the structure of second equation. We will see how to draw this structure. Okay, see here. Now for this structure, w of n is the output, x of n and w of n minus 1, w of n minus, these are the inputs. Okay, see here, x of n, this is my first term, right? So x of n, so I have to add with, so I have to add with a subscript 1 w of n minus 1, right? So this is my w of n, right? So I am adding x of n. So w of n, this is the delay element. So what is the output of this delay element? Wn minus 1. W of n minus 1 is multiplied with coefficient minus a1. This is minus a1. Now here it becomes, here there is a plus symbol. This is our plus symbol, right? So now I am adding this minus a1 w of n minus 1 with this. Then this output is added with the x of n minus a1 w of n minus 1. I got these two as a output. Now I have to add this term, right? So I need w of n minus 2. We shouldn't write here minus 2. Okay, if you are writing like this, right? I have already taught this one, right? Z to the power of minus 1, z to the power of minus 1. The output is, what is the output? The output is here z to the power of minus 2. Okay, here the output is w of n minus 2. Okay, w of n minus 2. Here, here the output is just you have to multiply this minus a2 coefficient with w of n minus 2. Now, with these two terms, I am adding minus a to w of n minus 2. Then only I will get this term. This term. The final element is, the final term is minus a subscript n w of small n minus capital N. So again z to the power of minus z to the power of minus 1, right? So w of n minus capital N. So you are multiplying with minus a to the power of n. So you will get, then you are adding with this adder element, you will get this one, right? So now I have drawn the first term, first equation structure. So now I have to draw the second equation structure. Now here y of n is my output, and b naught, b1, b2 are the coefficients. W of n, w of n, w of n minus 2. These terms are my inputs. Y of n is my output. So y of n, this is y of n is the my output. So here w of n, right? W of n is my input, right? So the first term is b naught is multiplied with w of n. So see here w of n is multiplied with b naught. So here in the output I will get the first term as a b naught w of n plus the second term is b1 w of n minus 1. For this I have to add one delay element. Now it becomes w of n minus 1, right? W of n minus 1 is multiplied with b1. So I have to add this term with the b naught w of n, right? So I got these two terms. Similarly, I have to add b to w of n minus 2. So this is my the output of this element is w of n minus 2, right? So I have to multiply it with b2. Again I have to add this term with the remaining two terms, and so on, right? So just I have to combine these two structure, right, in order to get direct form 2 structure. Okay, see here the final, this is not a final structure, just I have drawn the two structures and I have combined. See the final structure is, see here in the direct form 2 structure. So the delay element, these are the delay elements are exist at the middle part. The adder elements exist at the sides. Okay, but in the direct form 1 structure, see here this is the direct form 1 structure. Adder elements exist at the middle, delay elements exist at the side. Okay, in the direct form 2 structure, delay elements exist at the middle, adder elements exist at the side. Okay, so now I have to combine this these delay elements as a single delay, because in this structure also I am getting delay elements, in this structure also I am getting delay. In the middle parts we have these two delay elements, so we are combining these two delay elements as a single. So after combining the delay elements, the direct forum 2 structure looks like this. Okay, I said the direct forum 2 structure is better than the direct forum 1 structure, because here the number of memory element requirement memory element requirements is very less. So in the direct forum 1 structure we need m plus n plus 1 memory element, right? You know very well, right? Here the number of memory element requirements, see here, m plus n plus 1 memory locations are required, right? So multiplication, m plus n plus 1 multiplications are required, m plus n additions are required. But in the direct forum 2 structure we need less number of memory locations when compared to the direct forum 1 structure. Here we are calculating the memory location using this condition, maximum of m comma n, right? For example, if the m value is 4, n value is 3, right? So number of multiplication is 4 plus 3 7 plus 1 8. Number of addition 7. Here 4 comma 3, maximum of 4 comma 3. So here I need only 4 memory location, but in the direct forum 1 structure I need 8 memory location, but in the direct forum 2 structure I need only 4 memory location based on this condition, maximum of m comma n. Okay, in the direct forum 2 realization, minimize the number of memory locations. It is said to be canonic. Okay, so in the next video we will discuss the problem related to direct forum 2 structure. I hope you will understand this direct forum 2 structure concept. If you like this video, kindly subscribe my channel, like my like my video. If you have any doubts, please put your doubts in the comment box. Thank you very much.